Yeah, so I'm Ted Willke from Intel Labs, and I'm really happy to be here to support my friend Carlos with the second GraphLab workshop. Those that were with us for the first one know that I talked about our collaboration we started with Carlos in late 2010 around large-scale graph construction that helped make the problem a little less toy for them, a little faster from end to end. But, you know, I wanted to start by answering the question that you might be asking yourself about why Intel's in this space to begin with, since we're all about hardware and that. And believe it or not, Intel is actually trying to help people discover the hidden relationships within their big data sets. And the reason is that we believe that there's a giant transformation going on in the data center. It should be no surprise to most of you that the systems of the future are going to be processing data in more and more amazing ways with big data analytics frameworks. And you may not know that Intel actually launched its own distribution of Hadoop back in February of this year, you know, basically with the mission of providing an enterprised version of the Apache open source release at the lowest cost with the greatest value and with just the right gaps filled to make it easy, performant, secure, and manageable. And I was pretty excited by that, and we've set up a whole business unit to deal with that distribution and things around it. And we're, you know, as Carlos mentioned earlier, though, big data processing goes beyond Hadoop MapReduce, and now we're excited about expanding into new spaces. That's what Intel's Graph Analytics operation is about. And so our approach is to keep it open. It's way too early for companies to be vying for all kinds of additional, you know, proprietary value that they may perceive. I really personally believe that open source is the way to go here for a long time to come, especially in the graph analytics space, but in Hadoop at large. And you know, our contribution is Intel GraphBuilder, this large-scale graph construction library for Hadoop that I'll talk about. But we've got other open source projects you should check out, you know, from improving query processing to the benchmarking of these systems and many other things. And we're looking for partners. So Carlos had a slide that looked a lot like this earlier, so we're very much like-minded about the fact that there's a whole spectrum of data processing out there, the type of programming model you would bring. The sophistication of the types of algorithms that we're solving are getting greater and greater, and that's driving us towards this object-level parallelism model. And I'm sure that in the future, with the work coming out of Berkeley on Spark and other frameworks, we'll see things in between as well, these two ends. But I think that Carlos referred to the Hadoop elephant as a white elephant. I'm not sure if it's actually still yellow, but I am sure that we have answered the question that we do have to move beyond Hadoop MapReduce. Although there is a possibility we can do much of this graph analytics within the Hadoop ecosystem, so let's not confuse the two. One's a programming model, the other one is a really healthy ecosystem, and I think there's a lot we can do within it. And you know, I come from a systems lab. We work on cluster computing problems, and we've started an operation to focus on graph analytics. I always take a system perspective on the problem, which is why we started that engagement with Carlos, and realized quickly how valuable GraphLab was, but the problem was that the analysis is really fast, but it took all day long, or much longer than that, to get the information into the system. Part of that's a tools problem. We solved that with Intel GraphBuilder. I'll talk about some of the other issues with that as well. Jeff here and Joe talked earlier about you know, the problems with data wrangling and getting good feedback, and that's a big part of this type of systems perspective as well. But the industry is really not going to benefit at large from this type of technology until the solution from end to end actually gets deployed. And it looks more like this than these computational engines we've been talking about. But I think that our community has the right people to do it. I've heard a number of talks today, and there are components discussed, if brought together right, will provide this solution. But back to GraphBuilder. So we created a really nice library for scalable graph construction, and we have a lot of ideas about how it can be more useful to the industry. The basic premise was, you should not be writing a bunch of scripts to feed a high-performant parallel graph processing framework. You should do the graph construction in parallel as well. There are plenty of companies that are sitting on large masses of data in various data stores that want to construct different graphical relationships out of it, and that is what GraphBuilder is about. Written in Java, runs as a Hadoop library, has a bunch of primitives that allow you to do the common things you do during graph processing, which I'll show you in a sec. And what's cool is you can go download it today. It's Apache 2.0 licensed, and we've already gone through months of beta work on it, and it's we've got a pretty good debugged version there, and we have some aspirations for the future. So what GraphBuilder is about is it allows an analyst or a data scientist or a machine learning scientist to focus on the part they should be focusing on, which is this problem of extracting interesting features from their data stores, adding tabulated information to build graph structures that become information networks that are cleaned up and transformed and checked in various ways, visualized, and once they're right, they end up getting partitioned across a data center in a way that we make these nice, good, high-quality cuts, even though it is NP hard, and we load balance the systems with the work. And we support the type of partitioning that GraphLab supports, and we're looking at various other types. I'll talk a little bit more about the partitioning problem. And ultimately, we want to serialize this out to make it serializable for other systems to ingest. It can be stored in HDFS and HBase and other stores. But like I mentioned, the important part is graph partitioning. It's a really hard part, and there are many questions that you have to go through to decide on a partitioning approach. And edge cut partitionings are quite popular. Carlos already indicated what's so great about vertex cutting methods. This library supports the vertex cutting method, and we also had to consider online versus offline partitioning algorithms. Since it is NP hard, we focus on heuristical approaches, and we're not using global information when we do these. We scale it with MapReduce, and because of that, we're not using global information. We use online approaches that are obliviously greedy and so on. And in fact, we had, with Carlos and in some of the papers we both published, talked about these different heuristics. And a couple of interesting advancements lately have been focusing on these ones called constraint-based heuristics. And so basically we can use, as you see at the bottom, we have, basically we take a hash map and we can decide on what shards we're going to consider for placement of an edge. And in one case we tried it with a grid layout, and on the right-hand side you see that we've also tried it with a torus configuration. And so you can see that, for example, a particular edge may be placed in any of the shards marked in yellow, or any of the shards marked in that funny, I guess, pink or skin color. And they're guaranteed to have some overlap between the shards they can be placed in. And this heuristic tends to improve the quality of the partitioning. And so we can quantify that by looking at the replication factor, which is, when we're cutting vertices, how many pieces do we cut each vertex into? That's the replication. And you can see from these algorithms we've tried combinations of random and greedy approaches, and with the grid and the torus constrained methods. And on the top, The torus constrained method wins, and it depends quite a bit on the type of graph, the structure of the graph, but for the PageRank and LDA graphs we studied, the torus constrained method wins, and the greedy heuristic win in the other case. In either case, the greedy was better. The constraint seems to add some good value, but sometimes the value is not that significant. So we continue to work on this. We'd like to get the replication factor to scale better with the number of machines, and of course be as close to a small number as possible. And it does matter. So in continued analysis, when we look at once you've finished the partitioning, the whole point is to see if you can improve the speed of graph processing. And so we can look at the time it takes to load the information into the graph engine. In this case, it was GraphLab, and the time to execute an algorithm. In this case, it was LDA analysis on GraphLab. So you can see that with the torus greedy approach, which had a really low replication factor in the previous slide, we get a significant increase in execution time. And it's not mind-blowing. It's not like the kind of speed-ups we get fundamentally from using graph analytics versus other methods, but it is significant. And I think we'll be working on this for a very long time to come. But stepping back from all of that and the GraphBuilder work that we have already done, it's interesting to see where all this is going. So, graphs have been used for a long time in supercomputing. Intel has actually been participating in graph performance challenges for quite some time. We're a top entrant in the Graph 500 and the Green 500 competitions. You might be familiar with those. And it started with simple different types of breadth first and depth first type search problems and mining of different graph statistics as you would do with Snap or Pegasus. And it moves on to some of the stuff that we've been talking about today with what happens when you add semantic information to it. So just like RDFs, if you've been around to know how those were used for the World Wide Web, graphs get really interesting when you can add all kinds of properties to them, arbitrary properties, multiple properties for vertices and edges. And it opens up a whole new type of mining, which is even more powerful when you combine it with machine learning. And that's what Carlos was talking about, although a lot of the problems today are either in the category, outside of the big data wizards, are in the category of we're doing machine learning on homogeneous graphs with one vertex type, maybe one edge value, or we're mining information off of property graphs with multiple values, but not a lot of combinations of both. And I think that's the way forward for the use of these graphs for most commercial purposes. And in fact, I'm intrigued by a particular problem you might have seen in KDD recently where, just to motivate this idea of a heterogeneous graph with different types of vertices, that it's interesting to note that if you look at how papers are related to the terms they use, the venues they're published in, and authors that use them, and you want to come up with a method of predicting co-authorship in future papers, you can look at for highly ranked paths through a graph like this. You can look, and there are many types of paths you can form, but it's really only interesting if you, first of all, you put together a heterogeneous graph with these types of structural relationships, and then you're willing to look at metapaths that transcend different types of edges. Different types of edges are those that are between different pairs of vertice types. So, for example, an author to a paper that references another paper back to the author, or an author to a venue to a paper to an author. And so by actually doing machine learning-based ranked analysis of those metapaths, you can get better results than if you look at just direct relationships between authors on the same paper to predict the future authoring of papers. So interestingly enough, in the study, that path that I mentioned through the venue was a lot more significant and predictive than a simple authors on the same paper. So I think we need to develop graph construction systems and processing systems that can analyze these types of graphs going forward. But for today, we're not quite there with our work, and I'd like to bring Ivy Zhu up, a colleague of mine from my group, that we're going to show you a couple of cool demos that emphasize the two areas in yellow here. So we've done some work on what can we do with GraphLab with its speed, on shortest path mining, and a simple machine learning problem. I think visually it's pretty cool too. So let's see if it actually gets pulled off. We might have a failure of our own here. You never know with these things. We're actually going to be communicating with our systems up in Hillsboro, Oregon. We have a small compute cluster there. Actually, for these problems, we need larger graphs. For these problems, it's just a handful of systems. But hopefully we can get it to display here correctly first. Looks like this is way zoomed in. That's fine. Echo back. It's probably good enough. Let's try that. All right, check it out. So here's the deal. We took the Wikipedia. Yes, I'm so sick of that set. Everybody's been using Wikipedia. Man, I am so sick of that. I dream about that set. I'm so tired of it. I can't wait until it's behind me. But we did it again, and we took all the people in it, and we had been doing with other types of objects, so this is kind of a cool demo. And so we're going to spin the wheels, and we can relate any of these people. So what's interesting about this is it's easy to do this. What we're going to do is try to find a connection between them. We're going to try to find the most direct connection between them, and what we're using as a heuristic for that is not only the shortest number of hops or the degrees of separation, but also the size of the pool that relates them. So you know that there are categories defined in Wikipedia. We spun it. We found this person, Justin and Juliana, and they're related with 2 degrees of separation through 2 interesting groups here. And then we've added the counts of the number of people in Wikipedia that are actually in those categories as well. What's so cool about that is it ran in real time on our cluster. I think it was 8 Xeon servers. And it actually calculated all the potential paths between them in real time after we had selected them here. Nothing was pre-computed. Let's show them the second thing. On the same systems, we can also do graph-wide belief propagation. So we're going to look at the entire graph here. We've taken the Wikipedia graph, all the people and categories in it, and we've seeded a small number with known preferences. But most of these, which are the gray nodes, sorry about that, it's a little bit crude. It is a demo. And you can actually even see most of these are gray. We don't know their preference. And we can seed it with prior information. And now you can see the path that we were just talking about between Juliana and Justin and the surrounding influence of the groups that they connect into. So what college groups they were in, where they lived, activities they do. And let's say they have a preference for vanilla or strawberry ice cream. Yeah, that's a popular one. So with this seed, we can run an experiment and quickly see that Juliana would be predicted to favor what? Strawberry, which today is green, 91% of the time over vanilla. So it's really cool what you can do with these graphs, and that was done, that belief propagation where we passed millions of messages about what one node's belief was about the other node's preference. That was all done on GraphLab in real time, and it didn't even crash. Damn. It wasn't scripted, it wasn't stored to a file, it ran on the machines, and it's been running all day long. So come over to our demo and we'll spin the wheel and see what we come up with. If you're in Wikipedia, maybe we can try you. All right, we're dealing with the physical plumbing here. Thanks a lot, Ivy. Now let's see if I can get my machine to work again. So, I think that's just the beginning. We're just at the beginning of the evolving use of graphs. The the data structures are becoming richer, the algorithms are becoming more interesting, but it's a good start. And it's really fast. I think we've done a great job as a community in dealing with that and getting that going. But I wanted to take a slighter, wider perspective here. Let me mention also that we've done some work with David Bader and Jason of Georgia Tech on Stinger, their time-evolving graph framework, and we built some Twitter graphs with GraphBuilder around the March Madness NCAA events, and you can actually go over and see their demo, and the graph is basically one handle, Twitter handle referring to another, and in real time you can see how the communications evolve on different subjects and what handles refer to what handles and so on, and you can do all kinds of interesting studies with it. So I think time-evolving streaming graph applications are coming along as well, and they're doing some great work. So GraphBuilder 2.0. Well, first of all, heterogeneous information networks, so we're very interested in that. I think maybe if we have so much compute power for building graphs and analyzing them, we'll probably just build every edge relationship possible and then have them at the ready to look at the data so we don't have funny projections through the information. I mean, that's part of the problem with graph construction. It presumes that you know what you're looking for before you actually finish the problem. And so you don't have any chance to go back and interact with your information unless you're willing to rebuild the graph. So let's look at as many types of edge dependencies as we can. And as Joe and Jeff were saying, I truly believe in this idea of progressive refinement, especially during the graph construction phase, because you're going to spend most of your time building these graphs and debugging, your inputs from your data stores. And we're working, of course, you don't want to do all this from the beginning, so we're going to work on incremental methods, not only streaming methods, but ways of adding new information to existing graphs that are in various states of computation on clusters. And I think a big one for GraphBuilder in particular is, even if you're not doing machine learning, there's a lot of companies and institutions that are interested in mining their graphs in graph databases and peeking and poking at the structures they have. And I think Neo4j and AllegroGraph and Infinigraph, these companies are doing a great job of bootstrapping that area of work, and we'd like to use this as a scalable ETL for all of those databases and conform to their bulk load interfaces. So I'm going to be talking about that, hopefully with a number of partners. And so stay tuned in 2013 for updates on GraphBuilder and some of this cool stuff we're going to do with it. But you know what? I got to tell you, I feel a little guilty here. I feel like I'm about to slam us for something I just did. And that is that whenever I'm trying to relate my work to someone, especially if it's in my family or my friends outside of work, they don't get it. And I think graph analytics is something that's difficult for a lot of people to relate to. And you might have had the experience of finding that it's hard for even people that are working on big data problems to relate to. So I kind of feel like, things like GraphBuilder, we're guilty of being in this rocket ship going at like warp 9 or a little bit faster with our graph analytics tools. And the research community and the big data pioneers and the open source community are kind of guilty of like going ahead and not trying to relate this back to the world that's kind of stuck in a standard orbit speed. All the beneficiaries out there. So yeah, people are still grokking Hadoop MapReduce, and graph analytics seems like it's warp 9. So I really want to talk a little bit about how to bring them all along. And I think it's great that we have these cool technologies. It's obviously a much broader problem than just graph construction, so we've got to look all the way to operationalized solutions, things that are actually put into use. That means that things have to be much more integrated, and they have to be usable by the operators and the analysts alike, and the departments that consume the information, and the other systems that consume the information. And we've got a lot of gaps there. And I just want to give you 2 quick case studies. So service providers. So you have the kind of customer who has a very clear business objective, but they're very frustrated with the data warehousing tools they have. They have analysts that are peeking and poking at stuff constantly, and they get all these very surgical answers, but it's very specific to particular customers, particular information in that set. Or they can ask broad business intelligence class questions and relate something to statistically to a group. They're getting courted by a huge number of people knocking down their doors with these solutions, and like I said, just getting their heads around what it's worth. And so when someone comes to talk to them about graphical machine learning or graph mining, they say, you know, what the heck is this for and why do we need this? But you can have a conversation where something happens and they go, wow, that is powerful insight. Let's do something together. Because they are sitting on a vast amount of valuable information. There's another type of customer that has a massive amount of diverse data and already knows that they have a graph problem and wants to do something about it. But they're not aware of the tools. They're not aware of how easy it may be to do something with this with some kind of integrated solution, so they're engaging academic communities and having them build this stuff from scratch. And you talk to them and go, well, you know, are you aware of the work by the Aurelius group? Are you aware of GraphLab? Are you aware of this? No, that's great. That's going to save us a huge amount of time. So let's go do something. And I find that to be really puzzling with all of this, with 553 people, I think Danny was telling me earlier today, and all of the action I see on the web in this area, I'm baffled. So what's the magic that's causing them to make the connection? Well, I think first of all, I'm proud of the rocket science, but we have to try to help them view it through a more familiar lens. This is about relationships, so maybe we shouldn't be talking graphs, you know, vertices and edges and things like that, and focus more on the value of it. And obviously, we talked a lot about usability today, and that's a new phase that we need to, I think I'm voting to push the accelerator on that phase and get going on it. And let's help each other elevate the visibility of the work that we're already doing. It's just not getting out to a wide enough audience. I don't know why. I'm seeing plenty of it. It looks like everywhere I go on the web, there's a graph in front of me. But people are still not seeing things they can leverage enough. So I think it's partly about adjusting our message as a community. It's partly about getting together and collaborating better and doing better promotion. This workshop's a big part of that. I think technology-wise, let me run through this because I know I'm running low on time and Michael's going to come up here and pull me down in a second. But I think we're getting really good traction on performance, right? Let's check that off for now. There are going to be performance problems, but I'm telling you, some of you are at the way bleeding edge in terms of, you know, cluster size and performance needs. Most of the industry is like miles behind you. And so I'm going to check that one off, at least for myself. And I think that we're making great progress on algorithms. Michael Mahoney and the MMDS workshop at Stanford, others have done a lot of plus versions of popular algorithms. Carlos ran through a bunch today. And I just talked about data models like heterogeneous information networks, and they're coming along. But where I see the problem is with the stuff that Jeff and Joe were talking about, which is, you know, the programming models suck, they're hard to understand, they're inefficient for the people that are actually going to do the programming and deployment. There's not enough feedback in terms of good data visualization. Data preparation is still, even with things like GraphBuilder, taking way too long, and it's way too manual and fraught with error. And we need to integrate these frameworks better. So we don't want to create a bunch of silos. That's not going to bring people to graph analytics. We have to find a way to bring this to the Hadoop ecosystem and to other tools that are already in use and make it work. So I think there are some trade-offs that we should consider. And yeah, this is still science below the line here. So with that, my call to action, that's what I'm really here for. I think GraphBuilder is great, but I'm more concerned about these larger questions. And so yes, I'm going to be focusing on usability. I'm going to be focusing on integrating graph analytics with other computational models so it doesn't become a siloed technology. And I'm going to work on promotion, and that's why I think it's important that companies like Intel are getting behind this, and yet we're going to keep this stuff open, and we're going to be part of the community and be good citizens. So check out my group. We're hiring. I need all these roles and more, and you're fabulous people, and thank you for the opportunity to talk to you today.